Good morning. Oh, I missed you guys already. I'm going to try a couple of videos here, so bear with me. I should have my GoPro on, I guess, so I'm doing this one-handed. We're going to start section 1.3 today, surface area of objects made from right rectangular prisms. And yesterday we talked about what a rectangular prism was, and we talked about overlap. So I'm just going to show you something. We're going to start today with cubolinks. So we talked yesterday about a cube. We talked about how a cube has 6 sides. And we talked about a composite object, and a composite object is kind of like a compound word. It's 2 or more objects stuck together to make a new object. So I'm just going to show you the basics of this today, and we're going to make a little chart, and we're going to link it back to Unit 4, linear relations, remembering a few things there. My nails look great, by the way. Okay, so we got our cube here. We talked yesterday that cube has 6 sides. So now we're going to link it together. We're going to make a composite object. It's a pretty simple one. It's just 2 cubes together. So here's 6 sides, and when I link these 2 together, okay, there's a couple ways we can think about this, but an easy way is just to count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And I always use different colored cubolinks so that I can keep myself organized. So if we were making a little T-chart here, and you might want to call this X and Y. So this is the number of cubes. So if you wanted to call it C, that would work too. And this is the surface area. And the nice thing about my cubolinks is that they're each 1 centimeter by 1 centimeter. So they're 1 unit cube or squared. So it makes things kind of handy. So we already talked, we got 1 cube has 6 sides, right? And then when we added another cube to our train, we could call it, we're making a little train, having fun today, we had 10 sides. So let's keep going. If I added another one, I'm going to add a pink one here. And now we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. So now we have 14. And if we added 4, pick a purple one this time. Sorry, I'm not doing a very good job with my video. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So now we have 18 square units. And if we go back to Unit 4, linear relations, as this goes up by 1, a steady increment, so this is going up by 4. Okay, and so I'm going to take you back. We could actually, so we're going to do a little bit of a review here. That's not what this is all important, but it's really important that we always tie back other units, is that we could create an equation from this. And if you remember, you check the increments that are increasing on the y when x is going up by 1, and we could say that y is equal to 4x, because this is going up by 4. Okay, and then we have to figure out for the constant, what, when we multiply this piece by 4, do we have to do to still get to 6? So 1 times 4 is 4, and we'd have to add 2. And let's check it, double check, because sometimes, you know, we luck out or something. 2 times 4 is 8, and 8 plus 2 is 10. 3 times 4 is 12, and 12 plus 2 is 14. 4 times 4 is 16, plus 2 is 18. So the neat thing is like if I had this whole thing of cubolinks, I could link them together. And I mean, it would take forever for me to count, but now I could jump all the way here, and I could say, what if I had 25 in my train? And I would say I could go 25 times 4, which is 100, plus 2, and I would have 102 for the square units of the surface area. So that's just a neat thing to do. All right, so after this video link, you're going to get a little assignment that just has to do with blocks, and we're going to talk about how you can come up with your own strategy, because this works when it's a train, but sometimes we're going to have cubolinks that are linked a little bit differently. So we might make a cubolink that looks like this. Bear with me because I'm using one hand here. I broke my cardinal rule of sticking them together. Just like this, okay? So now let's talk about this one. We have a cubolink that has 1, 2, 3, 4, 5 of them, right? So separately, that would be 30. But the number one thing we talked about yesterday that I wanted to teach you before we left was that there is overlap. So these things are connected not only here, but here and here and here. And every time 2 cubolinks touch one another, that's 2 sides that are taken away, right? So one of my strategies when I first introduced this is to call these things by sides. So I've got a top, I've got a bottom, I've got a front, I've got a back, and I've got a side, and I've got a side. That's one strategy to do this, okay? That's what we're gonna talk about today. So I would write that down. I have 5 cubolinks. I'm gonna take a look at my top view. And in my top view, I have 1, 2, 3, 4, 5. 5 units squared. Now I'm gonna do my bottom. 1, 2, 3, 4, 5. 5 units squared. And now if I did my front, if you take a look at that, and this actually works better on my phone, I can see 3. I'd write that down, 3 units squared. And now I look at the back, and the back, it looks a little different, but it's still only 3 units squared. And then if I look at the side, I can see 2. So I could call that right side, or I could just call it side 1. And then if I take a look at the other side, it's weird, but I can still only see 2 units squared if I called that left side. And so now total surface area means we add them all up. That's what total means. 5, 10, 13, 16, 18, and 20 units squared. So let's just see, let's go back and see if our chart works for this though. If I have 1, 2, 3, 4, 5, 5 times 4 is 20, plus 2 is 22. So we can see that when we start making a shape, a composite object that isn't a straight train, we have other overlaps that are going to come into play. Now, another way that I've seen this done, and I'm a person who needs to count things out, so sometimes this is a little bit scary for me. You can go like this. There's 1, 2, 3, 4, 5. And separately, if I had each of these ones sitting separately, they each have 6 sides. So you go 5 times 6, which is 30 square units. Now we know that that's not right. So now we count overlaps, and we just talked about this. Every time a square meets another square, or cube, sorry, meets another cube, we have an overlap of 2. So here's 1, 2, 3, 4, 5 places that we meet. So overlap. There's 5 of them, they're each worth 2, and now you subtract that and you get 20 units squared. And you can see that our answers are exactly the same, right? So just 2 different strategies, and you have to use the one that makes the most sense for you. Okay, so I'm gonna stop here for a minute because that's 7 minutes and 37 seconds of my soothing voice that you've listened to. Okay, and then I'm going to put up a small assignment, and then you can try it, okay, and you can send me some feedback or text me or talk to me on the Google Classroom. That works too. And I'm hoping that we're going to be able to do this day in and day out. And I miss you guys, and this has been hard for all of us, but today would have been a popsicle day. All right, love you guys, miss you.